Today, we are diving into a really cool new paper that might just completely change how AI learns. We're talking about giving it something that looks a lot like an instant photographic memory. So let's break down how this crazy new tech works. I want you to just imagine this for a second. What if you could feed an AI a 1,000-page user manual or a super complex legal document, or maybe even your entire chat history, and have it learn all of it instantly and permanently? That's the huge promise we're looking at today. But to really get why that's such a big deal, we have to start with a pretty fundamental problem. You see, the large language models we all use every day, like ChatGPT or Gemini, they have this surprising weakness. They're actually not that great at remembering things for the long haul. They kind of have two different modes for memory, and honestly, both of them come with some major drawbacks. So let's break that down. On one side, you've got its short-term memory. The best way to think about this is the context window. It's like a little digital sticky note. You can write info on it, the AI can read it, but it's temporary, and it's pretty small. Then, on the other side, you have its long-term memory. This stuff is actually baked into the model's core programming, its parameters. This knowledge is permanent, for sure, but changing it is like trying to republish an entire encyclopedia. It is incredibly slow and super expensive. So you might be thinking, okay, why not just use that short-term memory, that sticky note? Well, because it's a huge bottleneck. For one, the information is transient. It just vanishes once the conversation is over. It's also really memory intensive, which is exactly why longer prompts cost more and are way slower. And here's the real kicker. The longer the prompt, the more the AI struggles to find the important bits. Researchers have a name for this. They call it being lost in the middle. So to get around all that, researchers came up with a method to move information from that temporary sticky note into the AI's permanent long-term memory. And yeah, it works. But as you're about to see, it is anything but fast. The process is called context distillation, and really the best way to picture it is like a long, painful all-night study session for the AI. The model literally has to teach itself what's in a document by quizzing itself over and over and over again until that information is finally burned into its permanent memory. And the process itself, it's just incredibly inefficient. First, you have to prompt an AI to generate a whole bunch of questions and answers about the document. Then you take those Q&As and you use them to slowly, painfully retrain the model. And what happens if you have a new document you want it to learn tomorrow? Yep, you have to do the entire, expensive, time-consuming process all over again. It's totally impractical for any kind of real-time use. So here's the bottom line, the number that really matters. Using this traditional context distillation method, it can take over 100 seconds to teach an AI a single document. In the world of instant information, that is an absolute eternity. But what if we could get all the benefits of that permanent long-term memory, but with the speed of a single click? Well, this is where a brand new method called Doc-to-LoRA, or D2L for short, completely changes the game. The conceptual jump here is just massive. See, instead of painstakingly teaching an AI the content of a document, these researchers trained a system that understands the process of learning itself. It's a meta-learning system. It hasn't just learned facts, it has learned how to learn new things efficiently. D2L pulls this off by creating something called a LoRA adapter. The easiest way to think of a LoRA is like a tiny, super efficient knowledge pack. It's a small little file of changes that you can just plug into a large language model to give it new skills or new information, all without messing with its core programming. And the D2L process? Well, it is just stunningly simple. The system reads a document one time, just once, and in a single forward pass, with no retraining, no back and forth, it instantly generates a custom LoRA adapter for that document. That adapter is the knowledge pack. And the result? D2L internalizes that exact same document in less than 1 second. I mean, think about that. We're going from over 100 seconds with the old method to under 1 second. That's not just an improvement, that's a breakthrough. Of course, being fast is great, but it's totally useless without accuracy. So the researchers put D2L through a whole series of tough tests to see if this instant knowledge was actually, usable. So the first test is a classic one. It's called needle in a haystack. What they do is they hide one specific sentence, that's the needle, something like the special magic number is 0042, and they bury it inside a massive document of just irrelevant text, the haystack. The goal is simple. Can the AI actually find that one little needle? And the results here are, well, they're just incredible. The base model, just using its regular short-term memory, It starts to fail pretty quickly, right after the document gets longer than its 8,000 token context window. But D2L? It finds the needle with near-perfect accuracy in documents over 4 times that length. We're talking 40,000 tokens and even more. It's not just remembering, it's remembering better inside much, much bigger documents. When you put them head-to-head, the practical advantage is crystal clear. Compared to the old-school context distillation, D2L isn't just a little bit better, it's orders of magnitude better. The update time, the latency, drops from minutes down to sub-seconds, and the memory it needs is way, way lower. This is what makes it actually possible for real-world apps, maybe even on your own devices. So what does all this actually mean for the future? This isn't just a small step forward. This could unlock entirely new ways for us to work with AI. Just think about it for a second. We could have AI assistants that are truly personalized, ones that have actually learned our preferences, our work history, everything. We could have news models that are constantly and instantly updated with the latest breaking info. Or how about a powerful AI running right on your phone that can quickly learn the context of a new document without ever sending your data to the cloud? But the paper saves its most surprising, most mind-bending trick for the very end. The researchers really wanted to push D2L to its absolute limit, just to see if it could transfer knowledge between completely different kinds of models. For this last experiment, what they did was they took a multimodal model, one that can actually understand images, and they used D2L to create one of those knowledge packs from it. Then they took that pack and they plugged it into a language model that had never ever seen an image in its life, a pure text model. The result? That text-only model was suddenly able to classify images from an image dataset with over 75% accuracy. Let that sink in. It learned to see, not by looking at pixels, but by having the knowledge of sight just plugged directly into it from another model. It's an absolutely striking demonstration of how flexible this kind of knowledge transfer can be. And that really leaves us with one final, powerful question. We are moving from a world where teaching an AI was slow and expensive to one where it could be instantaneous. So what becomes possible when an AI can learn anything you need it to, right in the moment you need it? The implications? Well, they're really just beginning to unfold.